Okay, so we've done a quick recap. We've done some practice with our mass, our mole to mole, and we've done our practice with some mole to mass. The next set that we're going to do are some mass to mole problems. Again, we will be using our chapter 10 skills along with our new stoichiometry skill of mole ratio. The process for going from mass to mole. Again, it's going to be a multi-step process. We always start with our given here. In this case, though, my given is given to me in grams. So if I have grams right here, could I put mole on the bottom of this? No. So it's not going to be the mole ratio. It can't logically work. So instead of going from our compound and then getting the mole value of the new compound, instead I'm going to have to first convert it to moles. So in this case, I'm going to be using molar mass. And I'll go ahead and put in of the given here. Now I would have the moles of the given, and then I would be able to use my mole ratio to convert between the various compounds. So our pathway here is I'm going to first convert to moles, and then I'm going to use the mole ratio to convert to moles of the new substance. And then that will give me my answer. All right, so for example, let's say, let's decompose some sodium chloride into sodium and chlorine. And then, of course, we have to make sure this is a balanced equation. And like I said, I'm using simple equations just because it's easy to see the coefficients and where everything comes from. All right, so let's say in this case, for our first example here, that we have a given of, let's say I have 125 grams of salt, NaCl. And my need is I need to know how many moles of chlorine gas would be created if I decomposed 125 grams of salt. How many chlorine molecules would I be creating? So, step one, put my given, including the compound and unit, and start my fence. The rules of dimensional analysis have not changed. What has to be here? Grams. So even if you don't memorize this pathway, if you know the process of dimensional analysis, which you should, I have grams, so I've got to have grams of NaCl down here. I'm either going to be using a mole ratio, which is moles and moles, or molar mass, which is mass and moles. And in this case, this is mass, and so it's going to be moles. The molar mass is the mass of 1 mole. And then I have to calculate the number of grams. If I am going to round here, sodium is about 23, chlorine is about 35, giving me a molar mass of about 58. So I've now gotten rid of grams of sodium chloride. I have moles of sodium chloride. I don't want moles of sodium chloride. I want moles of chlorine. So I got to take another step. The only way I can go from moles of one substance to moles of a new and different substance is to use a mole ratio. If I have moles of sodium chloride here, I have to have moles of sodium chloride on the bottom, which means the moles of my unknown, which is chlorine, is going to be on the top. Where do the numbers come from for a mole ratio? The equation. So I have 2 moles of sodium and 1 mole of chlorine. Moles of sodium chloride have canceled out, and I am able to calculate moles of chlorine. Multiply across the top, 125 divided by the bottom, 58 times 2. And I get 1.08 moles of chlorine. Questions? All right, use the same equation. You try one. See if you can do it on your own. And let's see. Let's say in this case, we've been given 72.5 grams of sodium, and we need to know how many moles of sodium chloride that was derived from. Give it a shot. See if you can come up with the right answer. I'll give you a few minutes to work, and then I'll work. Whenever you're done, you can look up, and I've put my work and answer on the board. Do what? Oh, did I put 75? Sorry, I got excited. I can fix that. My denial of needing to wear glasses is intense. 3.15? That's much better. Good call, Macy. Thank you. All right, did y'all get it? Yeah? I'm told stoichiometry is the hardest thing we do in chemistry.
I got 12.6.
Do you have it set up like mine?
Yeah, everything's the same.
Okay, then multiply across the top.
Yeah.
And then hit equals, and then divide by parentheses around the bottom. Or you could just,
never mind. I saw what it did.
yeah. Or you just recognize the 2 and 2 cancels out, so it's 72.5 times divided by 23. Anybody? Okay. Let's move on then. If we can do mass to mole and we can do mole to mass, then there should be no issue with doing the longest stoichiometric problem, which is mass to mass. In mass to mass calculations, you're going to be using molar mass and mole ratio because, you know, that has grams and the other one gets us from one compound to another. Still using dimensional analysis, that does not change. So I have my given listed first. Then this step right here, I'm going to have the molar mass of the given, of course, because that's here and that would have to match out. Then I'm going to have mole ratio. And finally, I'm going to have the molar mass of the unknown. All right. So let's we have to have a balanced equation, of course. Okay, so here's my balanced equation. Iron oxide plus aluminum yields iron plus aluminum oxide. And it's balanced. I've got my coefficients there. So let's say in this instance, I have been given 119 grams of aluminum. And we need to know how many grams of iron would be produced. So again, I know I'm doing stoichiometry because I have two different compounds. They're not the same. And if I'm doing stoichiometry, I know I have to use a mole ratio. So being that these are both in grams, though, then I know not only am I going to have to use that mole ratio, I have to use a molar mass. So I'm going to follow the path for right now, but hopefully as you get used to doing these and you practice them, the path will make sense to why it's the path. Step one, I'm going to put my given, including the unit, and get started. If I have grams here, I have to have grams on the bottom. The part of stoichiometry that contains grams is molar mass, which is the mass of 1 mole. So 1 mole of aluminum, and I looked this up on the periodic table, is 27 grams of aluminum. Step one. Now I've gotten rid of the grams part, so I've got moles, and that's good because I have to use a mole ratio. And if I have to use a mole ratio, then I have to have something in moles to do that with. So now I've got moles of aluminum. So I'm going to have moles of aluminum here. Even if I have no idea what my next step is, I know that these have to be the same. But since I have moles of aluminum and I'm trying to get to moles of iron, this is a great place for me to use my mole ratio. The moles of aluminum compared to the moles of iron. To find those, I look in my balanced chemical equation. I locate aluminum, which is 2, and then I locate iron, which is 2. Now, if I stopped right here, I have moles of iron. I don't want moles of iron. I want grams of iron. And the only way you can go from moles to grams is to utilize the molar mass. Since I have moles here, I've got to have moles here. And if this is molar mass, it's the mass of 1 mole. And then is it 55 or 56? 56. 56 grams of Fe up here at the top. And now I'm ready to calculate. You must multiply all the way across the top, then multiply across the bottom, and then divide the bottom into the top. So 119 times 56 equals, and divided by 27. And I get 247 grams of Fe. Questions? Nope. Good. All right, you try one. We'll use the same equation. All right, give it a go. See if you can get the right answer. I'll let you have like a minute's head start, and then I'll start working it out. All right, my work is on the board. Good. Hardest thing we've done. I don't think it's that bad. I like stoichiometry. But I did choose to spend my life, teaching chemistry. So clearly I like the stoichiometry. Anybody have any questions? Yes, Julie Ray. 164. That would be it. It happens. Anybody else? That's a good question. Can't get it right if we don't know where we're starting. Okay. Then we're not finished with stoichiometry. We're going to include probably tomorrow. I'm going to include things like atoms and molecules and formula units and liters. It's the same chapter 10 material. You're still going to be using mole ratios. The difference would be, instead of asking for I gave you grams. What if I asked you for liters of aluminum? My last step, would it have grams in it? No, it would have what? Liters. And how many liters is equal to 1 mole? 22.4. So tomorrow we're going to practice incorporating all of our chapter 10 skills in with these skills. And then we'll practice again all day Friday. And like I said, we may even wait till Tuesday, Wednesday to do our test over this next week. We'll just see where we are. Okay. So I'm going to give you some practice right quick, but only get this stopped for our at-home